Good day everyone, I am Jandel Dayok and today we will gonna solve for the hydrogen light wave function of I orbital with a principal quantum number of 7, angular quantum number of 6, magnetic quantum number m of positive and negative 3, and spin quantum number ms of negative 1 half. So the formula for that we are gonna use is psi in a function of r, theta, and p is equal to r, which is our radial function, and theta times p, which is our spherical harmonic function. We will now denote the hydrogen-like atom-bound state wave function by three subscripts that give the values of Rn, L, and M. So psi n, L, and M is equal to RNL SLM theta 1 over square root of 2 pi E I M E. As you can see, radial factor in this wave function depends on N and L, but not on M, while our spherical harmonic function depends on L and M. Now, in order to solve this, we need to normalize the function. The function r squared in the function of r squared, which determine the probability of finding the electron at a distance r from the nucleus, is also called the radial distribution function. So psi sub 7, 6, and positive negative 3 is equal to r, theta, and phi. Now, let's solve for the radial function using the equation r sub nl in a function of r is equal to r raised to l e raised to negative z over r over na. Summation of bj r raised to j from 0 to n minus l minus 1. Substituting n and l values will give us r raised to 6 e raised to negative zr over 7a bo r0, since our j value is equal to 0. Now, it is equal to b0 r raised to 6 e raised to negative zr over 7a. As we said from the previous slide, we need to normalize the function. So for the normalization of the radial function, 1 is equal to the integral of r conjugate times r squared dr from 0 to infinity. 1 is equal to b sub 0 squared integral of r to the 6 e raised to negative zr over 7a times r to the 6 e raised to negative zr over 7a r squared dr. We can move out the bo from the integral since it is a constant. Now, 1 is equal to bo squared integral of r raised to 14 times e raised to negative 2zr over 7a dr from 0 to infinity. Well, if you come up with these terms or terms like this inside your integral, you can use the formula that will be given in the next slide. So for the integral like x raised to n times e raised to negative alpha x dx from 0 to infinity, you can use n factorial over alpha raised to n plus 1. Substituting r 2z over 7a in alpha, and Rn will give us 14 factorial over 2z over 7a raised to 15. Solving for VO, we will get VO is equal to 2z over 7a raised to 15 over 14 factorial raised to 1 half. Then, so our radial function will be R76 is equal to 2z over 7a raised to 15 over 2 times 1 over 14 factorial raised to 1 half times r raised to 6 e negative zr over 7a. Next is the solution for the theta function from the spherical harmonic function. So the equation is theta is equal to sine squared raised to m over 2 summation of aj times cosine theta raised to j, limit from j is equal to 0 or 1 to L minus M. Substituting the value of R, L, and M, we now get sine squared raised to 3 over 2 summation of A1 cosine theta plus A cubed A sub 3 cosine cube theta. L and M will give us a value of 3. So, the values that RJ will be using is from 1 to 3. This will result to the formation of two terms of cosine theta. But this term with A sub 3 is needed to write in terms of the lowest A. In this case is the A1. So, we need to use the recursion relation for the conversion of A3 to A1. So, the formula for the recursion relation is equal to Aj plus 2 is equal to bracket J plus M times J plus M plus 1 minus L times L plus 1 over J plus 2 times J plus 1 Aj. Substituting the value of J that you want your A to have in the equation. Example, A3 to A1 with J is equal to A1. We now get 1 plus 3 times 1 plus 3 plus 1 minus 6 plus times 6 plus 1 over 1 plus 2 times 1 plus 1. A1 is equal to 20 minus 35 over 6. A1 equals to negative 22 over 6A1 and equal to negative 11 over 6A1. So, substituting this A1 into our original equation, theta is equal to sine squared 3 over 2 A1 cosine theta minus 11 over 3 A1 cosine cube theta. Then, theta is equal to A1 sine cube theta cosine theta minus 11 over 3 cosine cube theta. So, normalizing the function, 1 is equal to integral of theta times sine theta d theta from 0 to 5. 1 is equal to integral of A1 squared sine theta raised to 6 times cosine theta minus 11 over 3 cosine cube theta squared sine theta d theta. We can move the constant A1 out from the integral since it is a constant. Now, 1 is equal to A1 squared integral of sine theta raised to 6 times cosine squared theta minus 22 over 3 cosine theta raised to 4 plus 121 over 9 cosine theta raised to 6 times sine theta d theta. Now, If you can recall trigonometric identities, sine squared theta is equal to 1 minus cosine squared theta. And substituting that to our equation will give us 1 is equal to a1 squared integral of 1 minus cosine squared theta close parenthesis raised to 3 times cosine theta squared minus 22 over 3 cosine theta to the fourth plus 121 over 9 cosine theta raised to 6 closing parenthesis times sine theta d theta. Now, expanding this term will give us 1 is equal to a1 squared integral of open parenthesis 1 minus 3 cosine theta squared plus 3 cosine theta raised to 4 minus cosine theta raised to 6 times cosine squared theta minus 22 over 3 cosine theta raised to 4 plus 121 over 9 cosine theta raised to 6 closing parenthesis sine theta d theta. Now, multiplying this term with this term will result to 1 is equal to a1 squared integral of cosine theta squared minus 22 over 3 cosine theta to the fourth plus 121 over 9 cosine theta to the sixth minus 3 cosine theta raised to 4 plus 22 cosine theta raised to 6 minus 121 over 3 cosine theta raised to 8 plus 3 cosine theta raised to 6 minus 22 cosine theta raised to 8 plus 121 over 3 cosine theta raised to 10 minus cosine theta raised to 8 plus 22 over 3 times cosine theta raised to 10 minus 121 over 9 cosine theta raised to 12 closing parenthesis sine theta d theta. Let's combine like terms with same colors and same exponent to lessen our terms. And that will give us 1 is equal to negative a1 squared integral of cosine squared d cosine theta from 0 to pi minus 31 over 3 integral of cosine theta raised to 4 d cosine theta from 0 to pi plus 346 over 9 integral of cosine 6 theta d cosine theta from 0 to pi minus 190 over 3 cosine theta raised to 8 d cosine theta from 0 to pi plus 143 over 3 cosine theta raised to 10 d cosine theta from 0 to pi plus 121 over 9 cosine theta raised to 12 d cosine theta from 0 to pi. Remember that the integral of cosine theta is equal to negative sine theta. Negative sine theta. So, we need to place a negative 1 correction factor so that we can have d cosine theta inside the integral. And as always, we can move out constants, constants, constant outside the integral. So, as you can see, we already distributed the cosine theta to each term. Now, evaluating every integral will give us 1 is equal to negative 1 squared bracket cosine cube theta over 3 from pi to 0 minus 31 over 3 cosine theta raised to 5 over 5 from 0 to pi plus 346 over 9 cosine theta raised to 7 over 7 from 0 to pi minus 190 over 3 cosine theta raised to 9 over 9 from 0 to pi plus 143 over 3 cosine theta raised to 11 over 11 from 0 to pi minus 121 over 9 cosine theta raised to 13 over 13 from 0 to pi. Substituting the the limit 0 and pi will give us 1 is equal to negative a1 squared bracket negative 1/3 minus 1/3 minus 31 over 3 times negative 1/5 minus 1/5 plus 346 over 9 times negative 1 over 7 minus 1 over 7 minus 190 over 3 times negative 9 minus 1 and times negative 1 over 9 minus 1 over 9 plus 143 over 3 times negative 1 over 11 minus 1 over 11 minus 121 over 9 times negative 1 over 13 minus 1 over 13. Distributing this multiplication, 1 is equal to negative a1 squared bracket negative 2/3 minus 31 over 3 times negative 2/5 plus 346 over 9 times negative 2 over 7 minus 190 over 3 times negative 2 over 9 plus 143 over 3 times negative 2 over 11 minus 121 over 9 times negative 2 over 13. So we need to determine the LCD to easily add all of these terms. 1 is equal to negative a1 squared bracket negative 2 over 3 plus 62 over 5 minus 692 over 63 plus 380 over 27 minus 26 over 3 plus 242 over 117. So our LCD is now 1285. Using that, we now have 1 is equal to negative a1 squared bracket negative 8,190 minus 50,778 minus 134,940 plus 172,900 minus 106,470 plus 25,410 over 12 over 12,285. Now 1 is equal to negative a1 squared times negative 512 over 12,285. Multiplying both sides with 12,285 will give us negative a1 squared is equal to negative 12,285 over 512. So the value of our A1 is equal to square root of 12,285 over 512. So the final answer for our theta function is equal to 12,285 over 512 raised to 1 half sine cube theta times cosine theta minus 11 over 3 cosine 3 theta. Lastly, to complete our wave function, we need to compute for the value of p, and we can use 1 over square root of 2 pi e raised to positive or negative 1 mp. Substituting our value of m, positive negative 3, to this term will give us 1 over square root of 2 pi e raised to 3ip and 1 over square root of 2 pi e raised to negative 3ip. Finally, our complete function will be psi 763 is equal to 1 over square root of 14 factorial times 2z over 7a raised to 15 over 2 r raised to 6 raised to negative zr over 7a times 12,285 over 512 raised to 1 half sine cube theta times cosine theta minus 11 over 3 cosine cube theta times 1 over square root of 2 pi e raised to positive 3 I p. And for our negative 3, psi 7, 6, negative 3 is equal to 1 over square root of 14 factorial times 2z over 7a raised to 15 over 2 times r raised to 6 raised to negative zr square root over 7 times 12,285 over 512 raised to 1 half sine cube theta times cosine theta minus 11 3 cosine cube theta 1 over square root of 2 pi e raised to negative 3 I phi. Now, to have a real hydrogen-like atom wave function, we need to combine our wave functions using linear combination of atomic orbitals or LCAO. So this will be done by adding or subtracting both functions that we have computed from the previous slides. So, psi prime is equal to psi 763 plus psi 76 negative 3. Normalization of psi prime is will give us 1 is equal to n squared integral of psi prime conjugate times psi prime d psi. 1 is equal to n squared integral of parenthesis psi 763 plus psi 76 negative 3 closing parenthesis times psi 763 plus psi 76 negative 3 close parenthesis d psi. Distributing the integral and multiplying these terms will give us 1 is equal to n squared bracket integral of psi 763 psi 763 plus integral of psi 763 psi 76 negative 3 plus psi 763 psi 76 negative 3 plus integral of psi 76 negative 3 psi 76 negative 3 d psi. Using Kronecker delta, if the value of I is equal to j, the value is equal to 1. And if I is not equal to j, the value is equal to 0. So this term and the last term, we have I is equal to j, while the second term and the third term, the I is not equal to j. So we will have 1 is equal to n squared times 1 plus 0 plus 0 plus 1 after substituting 1 and 0. So the value of our n is equal to the square root of 1 half. Now, adding it in our original wave function will give us psi prime is equal to 1 over square root of 1 half 1 over 14 factorial raised to 1 half times 2z over 7a raised to 15 over 2 r raised to 6 times e raised to negative zr over 7a times 12,285 over 512 raised to 1 half sine cube theta times cosine theta minus 11 over 3 cosine cube theta times 1 over square root of 2 pi times e raised to 3ip plus e raised to negative 3ip. Now, using Euler's relation, e positive negative I theta is equal to cosine theta positive negative I sine theta. For our e 3I phi plus e negative 3I phi, it will become cosine 3 phi plus I sine 3 phi plus cosine 3 phi minus I sine 3 phi. The answer for this term will be 2 cosine 3 phi. So, the final real hydrogen-like atom wave function of n is equal to 7, L is equal to 6, M is equal to positive and negative 3, and spin of negative 1 half is equal to psi is equal to 1 over square root of 2, 1 over 14 factorial raised to 1 half times 2z over 7a raised to 15 over 2 times r raised to 6 times e raised to negative zr over 7a times square root of 12,285 over 512 sine cube theta parenthesis cosine theta minus 11 over 3 cosine cube theta closing parenthesis 1 over square root of 2 pi 2 cosine 3 phi beta. Beta is for the negative 1 half spin. Thank you for listening.